Ho, ho, ho! Ho, ho, ho! Can you hear this? Ho, ho, ho! Hi! This is Jose Luis here at Parametric Cam, and welcome to that video that is approaching that season of the year to be merry. Okay? And in order to celebrate the approaching Christmas, I'm recording this in November right now. I have made this video. I'm going to take this off because the sound is not going to be great. I have made a small mini series of videos where I'm going to teach you how to design a sequence of illuminations for a Christmas tree wrapped in a set of LED lights with controllable RGB values. What does that look like? Well, you can see that here I have this three-dimensional representation of a Christmas tree that I am drawing from a CSV file with XYZ coordinates of where those lights are in three-dimensional space. How I got those coordinates is a whole different story. I will explain that in a bit, but we're not going to cover this in this video. But long story short, I was able to bring them into Grasshopper with some errors. So there are a few outliers, but anyway. So, and then what I would like to do is I would like to generate sequences of illumination for that tree that may actually take into consideration where they are in three-dimensional space. In this video, in this first video, I would like to teach you first, imagining that you already have those sequences of illuminations, and those are going to look something like this. They're going to also be a CSV file that is going to contain a column for the frame that we're going to be rendering, and then 3 columns for each one of the LED lights with the values of the red, the green, and the blue channel. We're going to load those dynamically into Grasshopper, and then we're going to create a simulation where we're going to read each one of those rows programmatically, and we're going to render them with this cloud of meshes that I have generated. And the sequence that I'm loading right now is a sequence that has this virtual plane that is going to be moving from the bottom to the top. So you can see that if I take all those CSVs and then I write this thing where I have a slider that is telling me which frame I can render, you can see how that plane, that tree, those lights are going to be moving up and down. But if instead of doing it manually with a slider, I were to do it automatically with a component that runs on a loop, you can see how this tree now is able to, we have a dynamic simulation that is able to simulate that sequence of lights that I have stored as a CSV file and render it. And you can see that if you have many different CSV files, you can now load, for example, lights that are blinking, right? You can simulate lights that are blinking. You can do red and green lights. You can load different sequences and render them over time, all right? And I don't know if you can notice, this is actually changing very smooth. I like very smooth transitions myself. Or you can just go haywire with rainbows and lights, and you can see how this is also moving. All right. Now, where is this coming from? This is coming from the work that Matt Parker from Stand Up Maths did, from the work that he did on one of his videos 1 year ago, where he bought a Christmas tree, he wrapped it with LED lights that were individually addressable. He wrote a calibration routine to basically use computer vision to figure out the three-dimensional location of all the LED lights. And then he wrote a bunch of Python scripts, a bunch of Python scripts to control that dynamically. So myself, with the help of some of my students, we were able to replicate part of this process. But instead of using Python scripts, I thought that providing Grasshopper tools and canning that those sequences to CSV files will make it a bit more portable and a bit more friendly to this community. And we actually built a tree that is right now sitting in my living room that we can illuminate with all of this. And in the second part of this video, when we actually create some sequences, I will hopefully be able to record those sequences running live on the tree. Okay. So without further ado, first of all, before I get into anything else, I would like to thank Matt Parker for his idea and for contributing some of the code that led to this. It was very helpful for us to put it together. And I would also like to thank my students Indrajit Haldar, Jessica, Amelia, and Dongyun for the help that they put in making this tree a reality. All right, that's very awesome. Anyway, that's the story. So this is going to be part one of the series. In this video, I'm going to teach you how to, given that you have the sequence already, how to simulate them. And then once we have the simulation tool built, then the second part of the video will be how do we write code that can generate these sequences. All right. Beautiful. Without further ado, let's go in and let's get started. Okay, let's get started. So what are we going to do? So first of all, let's make sure we have the right setup. The right setup for this video, where we're going to first create the simulation of the Christmas tree, is going to be the following. So if you're watching this video, please go to the description and go to the GitHub repo. And in that GitHub repo, you will be able to download these two files that you're going to need to start working with this video. One of them is going to be what's called pcampTreeCoordinates.csv. And if I double click and I open Excel, what you can see is that this file is a very simple file that has a header that tells us that each row first has the ID of the LED, and then the other rows basically have the XYZ coordinate of where each one of these LEDs exist in 3D space. Theoretically, for a simulation, we could make this up, or we could just, but since we measured this on the tree that I'm going to be working with, it's kind of nice to have this tree shape sort of situation for the simulation. Otherwise, you could make this up, or you could work with some other arrangement of points in three-dimensional space. It doesn't really make that big of a difference, but if you want to use this, you're more than welcome. The other thing that I would like to show you is that you're going to need this movingplane.csv file. What is this file? This file is, and we will see this in the next videos, this file is a CSV file that contains what the RGB values of each one of the LEDs is going to be at every frame of the simulation. All right, so if you look at the header, you can see that the first column is the ID of the frame. So the first frame, the second frame, the third frame of the simulation. And then RGBs for LED 0, RGBs for LED 1, RGBs for LED 2, and so on and so on. And you can see that if I go down, you can see that the first 20 frames, LED 0 is going to be completely off. It's going to be black. But you can see that in this simulation, very soon, the LED is going to get brighter, 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 and then it's going to go dimmer, dimmer, dimmer again. And then for the rest of the simulation, it's going to be off. So it looks like this kind of, this simulation for some reason have most of the LEDs off, but then it turns them on. You can see how LED 1 has a very similar behavior, but it happens a little bit after time. And then here, these LEDs also have a similar behavior, but even more delayed on time. So we will see the effect of this. This is a CSV file that already has a sequence of illuminations that I did in the past. We're going to start working with this file just for the sake of having something to simulate. But in the next videos in this series, I will actually teach you how to generate these CSV files, which are the ones that I'm using to feed into the tree. Okay, so these are basically a way of pre-recording in some kind of file format the illumination sequence that each one of the LEDs on the tree should carry over time. And time, in this case, is going to be measured by frames. Second, we want how many frames per second we want the tree to run on. Okay, so you're going to need those two files. You can download them from the link in the description, the GitHub repository. There should be copies of these files that you can start working with. And then what we're going to do is, first of all, we're going to do three things in this video. The first thing we're going to do is we're going to take this file, all right, the file that has the coordinates of the tree. We're going to load them in Grasshopper, and then we're going to display these points in three-dimensional space. That's going to be the first thing. The second thing we're going to do is we're also going to load all these CSV files for the sequence of illumination so that we can choose every single frame. We can choose a frame on this simulation, and then we can generate the list of colors for the LEDs for that frame and simulate them on the tree. And then after that, and simulate them virtually in Grasshopper. And then after that, we will improve that simulation so that we can run that over time cyclically in a loop. And then we can see the simulation dynamically change over time. All right. So let's start with the basics, and let's start with figuring out how to load this CSV file with the coordinates and turn them into a cloud of points in three-dimensional space in the simulation. The way we're going to do that is the following. It's going to be quite simple. So Grasshopper has a component that is called read file. And if the file is a file of text, then this component is able to go through the whole file and read each one of the lines and then turn them into a list of strings in a panel or in a list. So what we're going to do is, given this, we're going to create a panel that has the full path of where the file with the CSV is in your system. In my case, it's on my desktop. So what I'm going to do is I'm going to feed this here, and then I'm going to read this. And then I see that I'm having some kind of problem, which means that, yes, I believe I cannot load that because it's still open. It's open with Excel. So actually something that I could do also, remember that CSV files are plain text files. So you can open them with anything. I think by default, Microsoft Excel associates these files with itself, but you can just open them in any plain text editor. So you can see that I'm using, for example, Visual Studio Code. I just dropped the CSV file, and now I can see each one of the columns with a different color. I believe the fact that I have CSVs, that I have different colors for each column, comes because I probably installed some extension, like for example, probably I have CSV lint or something. I probably have some extension that I downloaded to make the CSV look with every column to look with a different color, which makes reading this a bit more, a bit easier. So I'm going to recompute this, and then this works now fine. Okay, and then you can see that I am reading each one of these. If each one of the lines and the CSV file, I'm reading it as one different item because this component is set up to read the file per line. So I'm actually going to disable this because I would like the whole chunk to be one chunk. Not actually, now that we talk about it, I'm either way. Let's just, I mean, maybe it would be easier to do it per line, but because we want to learn a little bit more also, let's just maybe let's just maybe don't do that. Okay? Or not. Let me think about this. All right, I think we're going to do it per line because I want to focus on spending time on tree related stuff, not CSV parsing at this point. So we're going to have each one of these as each one of the coordinates of the tree as a different string. Okay, so what are we going to do then? What we're going to do is we are going to, first of all, we're going to remove the header from this. We're going to remove the header from this list. So what I'm going to do is I'm going to create a sublist item where I'm actually going to split the list, split list, and I'm going to split the list at item probably number 0. Is that correct? So that the top becomes and the bottom becomes, okay, so then it's going to be item number 1. And you can see that now the list on the top gives me a header and the bottom gives me the coordinates of all the points and their IDs, which is where I want to be. And then what I'm going to do is I'm going to write a C# script component so that I can take the coordinate of each one of these elements and then turn that into a part. All right. Because this list, because the data that is coming here is a list, I could be inclined to think that maybe I should change the access to access type of list. But since the operations that I'm going to do to take this whole string, split it in chunks with the commas, and then take this and turn them into numbers, because the same operation, I'm going to be doing it for every single line, then I actually don't need to care about bringing in the whole list. What I can do is I can perform that same operation per line, or in this case per item, and then spit out a list of points. So what I'm going to do is I'm going to make sure that this goes in, maintain item access so that I work with each coordinate, each line at any given iteration of the component. And I'm going to make sure that the input here is of the type string, because this came from a file. So all of this, even though it's numbers, they're actually of the type string, and I will need to split it by commas and turn those into an actual point in 3 dimensions. And then once I'm here, now I can now start writing some code to turn this coordinate, which right now is a string with ID and the 3 coordinates separated by commas, and turn that into a point. How are we going to do that? It's actually going to be super easy. Let's take a look at this. So remember, what we want to do is we want to take each one of these lines that has a bunch of numbers separated by commas. And what we want to do is we want to split those numbers by their commas and then cherry pick the ones that we need in order to recreate them into the coordinates of a point. So what I'm going to do is, first of all, I'm going to split the string by the commas, and then I'm going to get all the elements separate from with the commas. So what I'm going to do is coordinate dot split, and then I'm not sure why I'm not getting suggestions, but what I'm going to do is I'm going to use the character comma as the separator. So you can see that I'm using here single quotes, which denotes characters in C#. Now, I'm not sure why I'm not getting autocomplete. It's unfortunate, but and is there any error here? No, there isn't. So it's unfortunate, but what I would have liked to show you is the fact that split, the return type, is an array of strings. So it's something like this. So what I'm going to do is I'm going to split the line by commas, and then what I will get in return is an array that contains first the 0, then first the ID, then the X coordinate, then the Y coordinate, and then the Z coordinate. All right. And actually, maybe if I output that, I will be able to see a version of that. So let me show you how that works. So yes, so you can see that for each line, the component is creating a tree that contains a list of the ID and the 3 coordinates. All right, the ID and the 3 coordinates. That's pretty neat. So then what we need to do after that is we need to make sure that instead of outputting arrays of values, that we turn these 3 values, the x, y, z, into the coordinates of a point. So what I'm going to do is I'm going to say, well, we could think of doing something like I say, point 3D is going to be a new point 3D, and then that is going to be taking parts.1, so the second element, right? Because we have the ID on the first one, parts.2 and parts.3. But if we do this, we're going to have a small problem, which is that doesn't work, because it turns out that even though these look like numbers from a type standpoint, because they came from a file that we read in the system, these are actually strings. There are strings that contain numbers, but from a type standpoint, the computer still sees them as screens, as strings. And that's why we're getting this error here that it cannot convert from string, which is this, to doubles, which is what it needs to create the coordinates of a point. So what we need to do is we need to actually be able to take these parts, which again are strings, and parse them into numbers and convert them into numbers. So how are we going to do that? We're going to do it this way. So what we're going to do is we're going to say, we're going to declare three variables, all right? And then what we're going to do is we're going to say x is going to be equal to a parsed version of parts one. How do we parse numbers? Well, we have a video in our Learning C# list where we talk about conversions between data types. So a link to that should be popping here in the corner, or it should be in the description. But for example, one way to do the code for about this is using the double object and then using the parse method. All right. The parse method takes a string, so that can be parts one, and then returns a value, a double. So the same can be done for the y coordinate, so that's going to be part two, and then the same can be done for the z coordinate, and that's going to be part three. And then here, this would be x, y, and z. All right. Now, what you can see now is that this actually worked well. All right. So this work, we have the points here. They were created from these values. The only thing that I would like to do though is, just for the sake of sanity, sometimes when we get stuff that is coming from CSV files, if whoever generated those files didn't take good care, or maybe there's some data corrupt, whatever, sometimes if this was actually something that could not be parsed into a string, into a double, then this will give us an error. So something that is very common to do is to wrap this inside of a try-catch clause, so that in case there is an error in the parsing, then there is no error, the program doesn't break. So I'm going to create an exception here, and then I would just say, well, if something doesn't work, take the exception, and then just create a message saying this is an invalid string for whatever reasons. Okay. Now I'm going to save this, and you can see that something didn't work. Okay, so error, use of an assigned variable. Okay, so I believe that after we wrap this, we need to initialize this, because maybe the computer thinks that when we get here, we may not have initialized the values and we have a problem. So we have that. And let me show you what that would look like if we actually had corrupt data. So for example, if we did this and I added, and I'm going to save this file, and I'm going to remove everything that I did here. Okay, that includes this, and that if there was no try catch, and I were to run this, you can see that I'm getting an error. The input string was not in a correct format, and this becomes a null element. And so what I can do is I can manually handle that exception. And then now what I get is that I get a default point at 0, 0, 0 instead of a null element. And here, invalid string, system was not in the right format, etc., etc. So what I'm going to do is I'm going again, and you can see that this now we have the points. And do we have the points? Yay, we do have the points in 3D, and they kind of look like a Christmas tree, but you can see that we have all these outliers here, which are not great, but that's because we're still working on a nice calibration routine. We got most of it done. We have a few outliers. It's not great, but we're working on it, okay? So, yes, so, all right. So we have the coordinates of our points here. So what are we going to do next? The next thing we're going to do is we're going to do something very similar. We're going to do CSV parsing, but in this case, what we're going to do is we're going to try to bring in the coordinates of the LEDs, the illumination, the sequence of illumination. We're going to bring it into Grasshopper and be able to simulate them line by line. Let's take a look at that. All right, so this is what we had before. This is reading the, what did I do? This is reading the coordinates of the points from the file. So now let's read the whole file that contains the sequence of LED illuminations. So that file looks like that in my system. This is the route, and this is the file of the name of the file, like I showed before. Okay, and then what I'm going to do is I'm also going to read the file with the same principle that I used before, okay? And then something is wrong. Yeah, I can't use it because it's being used by another system, so I will need to shut it down from Excel. Excel puts like a hold on file, which is kind of not nice. So I'm going to recompute, and then I now have the file per line. And if I plug this into, you can see that this is actually very, very slow because the file is very heavy. Grasshopper panels are not great at displaying lots of data. So I'm going to turn that off for the time being. And then just like I did before, I'm going to remove the header because I don't really need it at this point. And I'm just going to stick with the bottom. So just with the rows that contain the data. So you can see that this row is row that would be frame number 14, and you can see the triplets of lights, and you can see that the triplets are always the same value, which indicates us that we're going to be, for this file, it's just going to be working with from black to white, basically. Okay. All right, beautiful. So what is the next thing we're going to do? The next thing we're going to do is I would like to take this CSV file. All right. I would like to be able to choose one of the frames, and then I would like to take that frame, parse the whole line that contains all the LED lights, and spit out a list of colors so that then I can render something with those colors. What are we going to do for that? So what I'm going to do is I'm going to write a CSV, a C# script component. I'm going to take here the CSV data, all right, which is coming from here. And for this one, for the reasons that I will explain very soon, for this one, I'm actually going to take list access. So I'm going to want to read the whole thing, all right? And I'm going to do that basically because I will eventually want to change these components so that instead of reading always the same line, it reads different lines over time. And for that, it's going to need access to the whole list of CSV lines. So I'm going to turn that into list access, and I'm going to turn that into string access. And then which frame do I want to render? So that's going to be a second input that is going to be item, and it's going to be an integer. And for the time being, I'm just going to put here a slider from 0 to 100. Okay. And then what I would like here is to output a list of colors. Okay. So what is that going to look like? All right. So let's write some code here. So I have a list of CSV files. Okay. Of CSV lines. And I have which frame do I want to read. So then from a standpoint, the first thing that I would like to do, I'm going to be a little more systematic here. So algorithm. So first thing that I want to do is select the row that contains the current frame to render. All right. So that's going to be, because I have a list of strings, then the only thing that I need to do is from that list, just retrieve the one that has this frame number. So current CSV is going to be equal to CSV and then the ID of the frame. All right. And just to test things out, I'm going to create a fake output test. All right. And I'm going to just use that to output stuff as I am developing. Okay. So what am I going to do? For test, I'm going to say, can I see what I just got? Current CSV. And then if I render that, you can see that I just cherry picked the frame with ID 100, where most of the initial LEDs are 0 and the ones at the end have certain different colors. And then if I were to change this, you can see that as I scroll, I'm picking up different CSVs from the list. Okay. All right, that looks good. What is the next thing that I want to do? So remember that each one of these rows first has the ID number, and then it has all the integers that correspond to the illumination of the RGB separated by my commas. So what I would like to do is I would like to get split the string into individual values. So I'm going to say, same as before, I'm going to say data is going to be equal to current CSV dot split with the character comma. And then if I output that, you will see that now this is changing. And now what I have is all the data without the commas in a array format. Okay? Beautiful. So, and you can see the triplets of color as numbers here. All right, so that's great. So the next thing that we're going to do is we're going to not use this. And something that could be interesting would be basically calculating how many LED lights do we have, which we kind of don't know, or it's not explicitly anywhere. But if we have the Christmas tree and we open the CSV file, we could count how many columns we have and divide by 3. Or we could just go to the end and be like, oh, the last one is 499, so it has to be 500 elements. But it's also very easily, we can probably do this very easily by saying, well, let me first say, I'm going to calculate amount of LED lights. So I'm going to say integer LED count is going to be equal to data.length, because it's an array, all right? However, the length has to be whatever the length is minus this first element, which is the ID number, and that we don't want to count in. And then all of this, remember, we have RGB values for each one of the LED lights. What that means is that we have 3 numbers for each LED. So therefore, the amount of LEDs should be the total length of the list minus 1 divided by 3 data points for each one of the LED lights. And I believe this should give us 500. So let's see if that works. Yay! It gives us 500. So it looks like the calculations are going well. So I'm actually going to formalize that into an output. And I'm going to output this as LED count. But now I'm going to have to change the name because I'm going to call this LEDs. That's not a great name, but anyway, LEDs is now 500. And I'm going to put here a small panel to see LED count. Correct. So this is looking good. Beautiful. What is the next thing that I would like to do? Well, now that I have all this data, what I would like to do is iterate over the whole thing. And what I would like to do is I would like to take each one of the 3 data points for each color. I would like to translate them from strings. Remember, these are still strings. I would like to parse them into integers. And then I would like to create color objects with that with those numbers. All right. So let's take a look at how to do that. First of all, I'm going to iterate over all the data points minus the ID. So what I'm going to do is I'm going to create a for loop that starts with I equals 1 so that we don't work with this one. All right. I is going to be less than what? Data.length and then I plus plus. With this, I is going to be iterating over all of these data points, starting with the one in position number 1. All right. And then what am I going to do? What I would like to do is I would like to take each one of these, which are strings, and convert them into data that I can use to create a color. The Grasshopper doesn't have a representation for colors. It uses the C# built-in representation of color. So that one is one that is called color, but if it's not loaded by default whenever we have a Grasshopper component. So here I'm going to need to add system.color system.drawing, and then system.drawing is the namespace that contains color objects. All right. When I create color objects, let's say I want to create a color called C. That is going to be that I can do that by either creating a new color or using color dot, and then first of all, there's a lot of static named colors that I can choose, or I can choose to create from ARGB values. So what does that look like? So I have 4 options: the one integer representing all the colors, 3 integers representing RGB, 4 integers representing alpha and then RGB, and whether if I just want to use a base color and give it some transparency. So I'm going to be using this one, which means that I need to convert these 3 numbers into into RGB colors. Okay, into RGB colors with integers. So now that I'm thinking about this, it turns out that because I'm iterating with for each data point at a time, then this may not be the best way to iterate, because I will not have access to all the stuff at the same time. So I'm going to rewrite this to a different way. I'm going to rewrite this, and then what I'm going to do is I'm going to say, first of all, I'm going to get a for loop that I'm going to iterate from 0 to the amount of LED lights, so LEDs. So the for loop is going to go, in this case, I is going to iterate between 0 and 500, all right? And now that I do that, then what I will need to do is, in order to read these values, I will need to figure out for any value of I, what is the value of the position of the data that corresponds to that I. So let me show that. So string RST, so that's going to be string for the color red, is going to be equal to, is going to be equal to whatever I have in data in a position that is going to be I is going to be 1 plus whatever I we are, and this 1 is basically the offset that we have because of the 100. And then this I, I'm going to have to multiply it by 3, because since we are jumping with triplets, okay, then I will need to, for the first LED light, I is going to be 0. So 0 plus 1 will be 3 times I. That was a terrible explanation. All right. But anyway, this is going to be 3 times I, because every time I want to jump to a new light, I need to jump 3 positions on this list. So the red color is going to be the first one of those 3. Then string green is going to be the second one. So it's going to be the same thing, but it's going to be offset by another. So that's going to be whatever the value for red we calculated plus 1 unit. And then this RGB B is going to be this same value, but with an offset of 2. All right. So this is the logic, and this is not very optimal, so we're going to rewrite this a little better later on. But then let's start with that, all right? And then what I want now is to actually have values for RGB, which I'm going to have to parse from this string. So I'm going to somehow have to convert from string to an integer. So I believe I can do that by saying integer 32 dot parse, and then take the string, so str red, so that's going to be the value of the red, and then the value of the green and the value of the blue will be str green and str blue parsed. All right, then color is going to be color dot from ARGB, and then here I can put RG and B. All right, and let me run this and see if I have any errors. I don't have any errors. Okay, that's great. But then I need to do something with this color. So what I will need to do is I will need to store it in some kind of list that then I can output here. So, so I'm going to do that by saying I'm going to create an array of color elements, colors, and that's going to be equal to a new array. And since I know the size, know that it has to be equal to the amount of LED lights. So what I can do now is I can say, well, instead of defining a variable, what I can say is colors at position I is going to be equal to this new color that I just created. This also works well. And then it looks like just I can now output this as the test. And you can see that the system already stringifies each one of these colors as triplets, okay? Which is kind of nice. And you can see how some of those are turning on and off. All right, so we are getting a list of colors for each frame. And then if I move the frames, you can see how each one, now the colors are changing. All right. Okay, so then let's just change this to colors, which is what I wanted. Colors is here, and then test is probably going to be gone. All right, beautiful. So now we have been able to take the list of colors from the CSV file. And then the next thing that I would like to do is I would like to use this and to color or to simulate the coloring in this Christmas tree somehow. How are we going to do that? With a very simple trick. So there are several ways we can use this information to render something on the screen that applies these colors to these points. Grasshopper has a few options there. So for example, if you go to display, you can see that on preview, there are these two options, dot display and cloud display. So for example, dot display, what it does is given a collection of dots and a collection of colors, then it is able to render them as circles. So for example, I'm going to plug in here the points, and oh, you can see that the points are huge. So I'm going to make them very, very small. So I'm going to reduce the size here. Yeah, and this component has actually been giving me problems. I think my Rhino is about to crash. Yes, so this has happened twice already while I was doing this. I don't know if it's my computer or if it's Rhino, whatever. So I'm going to open Rhino again, and I'm going to try again. I believe. Okay, so oh no, so this is not the one I was working with. This one here. So I'm going to drop the display here. I'm going to drop it again. I'm going to plug in the points and then here in the perspective, and then I'm just going to set the value to something very small right away so that I don't scroll. I'm not sure if that's the problem that I'm having. Okay, so 0.02, and you can see that the points are now smaller. And then you can see that one of the inputs here is the colors. So if I use these colors here now, you can see how these colors in the bottom are whiter and the ones on the top are black, or basically they will not be illuminated. Okay. So actually, in order to see this better, I'm going to change the viewport of Rhino, and I'm going to turn the background to pure black. So we're going to imagine, so I'm going to go to appearances, color, and the background, I'm going to change it to all black, and I'm going to press F7 to turn the grid off. And actually, I'm not going to turn the background full black. I'm just going to make it a very, very dark gray so that I can still see the dark spots of the LEDs that are not illuminated. All right, so that's one option. But this option has been a little buggy and not giving me a hard time. And also, one thing that I don't like about this one is that I cannot see transparency through this. I cannot see transparency in this in the lights. One thing that we could do is, for example, when we create the color, you know how the color is created from RGB values? Something that we could do is, instead of creating from RGB values, we could give it some transparency. We can give it an alpha. So something that we can do, for example, is say, I'm going to calculate an alpha that is going to be R plus G plus B, so the three colors, divided by 3. All right, I'm going to just average the 3 channels. In our case, because we're working with grayscales, it's not going to be very meaningful, but in the case of that we were working with colors, this could probably be quite meaningful. So, and then I'm going to add here this alpha value, which again is just the average of the other 3 channels. You can see that in the display, we get now this parenthesis, which is the alpha value, which is the same for all the rest, so it's not really making anything different. But this color now has an embedded alpha, which is not showcasing with this visualization. So I'm going to remove this one. And then what I'm going to do is I'm going to plug in this other one called Cloud Display. Cloud Display, I'm going to also plug in the points. I'm going to plug in the size, and I'm going to plug in the colors. And you can see that this kind of looks a little better now, but you can also see that because black pixels are fully transparent, there isn't really, they're missing something. So something that I could do is I could say, well, if A is equal to 0, if A is less than, for example, 25, so let's make sure that A at least has a minimum value of transparency, okay, for example. And then you can see very, very faint, you can see the rest of the dots, all right? But you can also see that if I actually have them overlapping each other, there's no transparency through. So I also don't like this technique, okay? So let me say here that I'm going to add a value that is going to be called minimum alpha, and that's going to be an integer, all right? And then we're going to substitute this minimum alpha, then minimum alpha, all right? So that we can play with this value. And I'm going to set here a slider that is going to go from 0 to 255, so that the minimum alpha has to be at least 255. In this case is full black, all right? But I could also make it more transparent. So you can see how now the dots are transparent with the background, but they're not transparent with each other, which is kind of weird. Or it is in a weird way. I don't really know. There's like a blurring effect here of some kind. Fuzzy, blurry bobs. Maybe I want blurry, but they're not transparent. Anyway, so I'm going to show you another technique that we're going to use here, which is going to be a bit more low level, but it's also going to give us the most freedom in this case. That freedom is going to be the following. What I'm going to do is I'm going to render actual spheres myself, and then I'm going to color them with a material in Grasshopper. So we might be inclined to say, well, then I'm going to use the sphere component, all right? And then I'm going to create as many spheres as points, and I'm going to make them very small, all right? But I'm not sure if you have noticed already how my computer was lagging a lot. This is because when you use NURBS geometry in Grasshopper, the generation of the geometry is actually very cheap, but the rendering is very expensive because internally, Rhino and Grasshopper has to convert this these NURBS into an actual mesh in order to render it on the screen. And this mesh, you can see that is very, very detailed, it's very defined because we don't see jagged edges. And therefore, it takes a lot of time to compute from a rendering standpoint. So what we're going to do instead is, instead of rendering NURBS, which need to be converted into meshes anyway, we're going to directly generate spheres that are meshes themselves, so that we are the ones who can control how defined that mesh is, how much detail it has, and then we can make decisions about how to speed the simulation up. So I'm going to do mesh sphere. I'm going to place this here. I'm going to place the radius here, and you can already see how for a very, very similar level of definition, I can still see the jagged, I can now see the jagged edges, but this is way faster as a simulation, right? And even for meshes that have lots of sides, they have 100 vertices each. I could make this even more low res by lowering the definition of the mesh. So for example, you can see, I'm going to zoom into one of these meshes. All right, you can see the boundary. And then if I lower this, you can see that these almost turn as polygons of sorts, but they're much faster to render now. Okay, so I'm going to stay with 5. And what I would like to do now is I would like to do a custom rendering of these slides, of these meshes. The way that looks like is that in the display, you can use custom preview, and then any geometry can be rendered with any material. This, I'm going to turn this off. You can see that by default, if I turn this off, the display material is this kind of, some kind of, I don't know what this is, some kind of pink plastic of sorts. So what we can do is we can create our own materials here. All right. So what does this look like? We have the diffuse. We can create our own materials. So we have, for creating materials, we have the diffuse channel, that is the plain color that by default here is pink. Then we have the specular color. So whenever we have a reflection, what color does that reflection look like? And the emission, which is a very similar concept. So we can also define the transparency from 0 to 1. And we can also the amount of shininess. So what I'm going to do is I'm going to take the values of color, all right, of the colors, and I'm going to use those to display the geometry. So the diffuse color is going to be whatever we got there. And you can see that now, very interestingly, I have the bottom is lighter and the tops are off. So that's kind of great. But you can see that the diffuse channel is not picking up the transparency that we created here in the color. All right. And actually, I'm not sure that that is being picked up. Oh yeah. Oh yes, exactly. So we have some degree of transparency, but that is not being picked up. We have the exact same problem. That is because the material needs the transparency as a needs to get the transparency. So needs to have the transparency as a different input. So what we could do is we could take the color, all right, and then we can split each one of the colors into each one of its individual channels: alpha, red, green, and blue. We could do that, so we can plug this in here, and then we have a value of alpha from 0 to 1, because this is now set to values from 0 to 1. We could do integer channels, and then it would be from 0 to 255. So from 0 to 1, and then I'm going to plug this in here. The problem though is that the scale of the alpha is, in this sense, it's the inverse of what the material component needs. So let me show you what that means. We have a value of alpha that for black pixels is very small, but it turns out, and then that becomes a very small number, 0.26. However, the transparency that this component expects is very low levels are very opaque and very high levels close to number 1 are transparent. So basically the scale is inverted. In our color scheme, here low values mean a lot of transparency and high values mean a lot of opaqueness. Whereas here it means the other way around. So we're going to need to invert this, and whatever is close to 0 must be close to 1 and vice versa. We could do this in Grasshopper, but why not do it in directly here with the colors? All right. So why not just say, I'm going to add here another component, another output that is going to be transparencies, and then let me calculate this right here. All right. So I'm going to add another array that is going to be another array of doubles that I'm going to be called trans for transparencies. And then it's going to be a new array of double elements with 500 items here. Then what I'm going to do is I'm going to keep the alpha as part of the color just because it's nice. But then here I'm going to do a small calculation where I'm going to flip that. And I'm going to say double T is going to be equal to whatever alpha is, we need to invert it, all right? And then we need to normalize it. What that means is that the value of alpha is going to be alpha. So the value from 0 to 1 of that transparency is going to be whatever value we have divided by 255. What that means is that if A is very high, then this will be closer to 1. And the other way around. However, we need to remember that C# works with integer division, and because A is an integer and 255 is an integer, the result of this will be also an integer, so over 0 or 1, not both. So in order to make sure that this is a real division, I'm going to write 255.0. Okay, so that would be the value of the that would be the value of the normalized transparency that I could output, and then trans dot in the I position is going to be the value of this. However, that is, if we look at that, we can see that now for each, and then I need to output that. So transparencies need to be equal to that array that I just created. All right. So you can see here, high value, medium value, high value, low values, low value. So it's kind of matching real well. So I could plug this in here already, but I'm going to have the same problem as before. The scale that this component needs is inverted. So for high transparency, instead of low values, it needs high values. So the only thing that I need to do here is, in order to invert that is going to be as simple as saying 1.0 minus this value. And if I do that, you can see that now low values have a high normalized, high values have a lower value, and you can see that these elements are much more opaque than the black ones that are on the top. And that if I were to increase the minimum transparency or decrease it, I can work with that. Yoo-hoo! Is this working? Can we see this happening? So let me scroll from frame 0 all the way to frame 2. Yay! And I believe this CSV has 151. So I'm going to write here 151. All right. And then, whoa, we can, yay. All right, beautiful. Okay, so this is working. Now we can create the simulation for each one of the frames that are contained in the CSV file that has the sequence of all the LED lights. Now, can we make this work? Can we change something here so that instead of animating this by frame, can we automate the simulation? Can we do this dynamically over time? Let's take a look at that. Beautiful. So I have cleaned things a little bit up. I've created a couple of groups here. Now this is the paraframe simulation group. And now all of this is taking just external information and rendering the LED lights. So what I would like to do now is make something very similar to this, but extend it so that I can connect a timer and then the simulation scrolls over the frames iteratively. All right. So what I'm going to do is I'm just going to copy and paste this so that I keep a record here of the per frame simulation. But now I'm just going to modify this. And I'm going to modify this so that, first of all, I'm going to remove frame because I don't want this anymore. What I would like to do is I would like for this to scroll over time. All right. And then, so now I don't want a particular frame to be the target. And then what are we going to do? So what we need to do here is we need to modify this so that what we do is every frame or every time we update this component, we render the next frame on the list. So what we're going to do here is, in order to do that, so that we can connect a trigger. so that we can connect a trigger here, right? And then we can say, I'm going to refresh this interval every 20 milliseconds. And then I'm going to get a new rendering here, which right now I have nothing going on, okay? So instead of that, what I would like to do is I would need to have some kind of figuring out every time this component gets updated, which one is the frame that needs to be rendered, which one is the frame with LED lights that need to be output by the component. What that looks like is that I'm going to need to have some kind of persistent variable that can change across different iterations or different updates of this component. And I already have videos where I explain how to create continuous execution in Grasshopper. There might be a video popping up in as a card here on the top left corner or in the description of this video. So make sure to check that out. So the way I'm going to do that is I'm going to go here to custom additional code and I'm going to create a new variable called current frame that I'm going to initialize to 0. All right. And then what I'm going to do here is that this is going to be the code that gets executed every time we update. And instead of using frame, which was the input, I'm going to use here now current frame, right? So this is going to be the code. And then every time this updates, what I would like to make sure is that current frame gets a new value. All right. So I'm going to increase update for next iteration. So what I'm going to do now is that every time this gets rendered, current frame is going to update by 1 unit and therefore is going to move to the next row on the list. How does that look like? If I press play here, I should be seeing something that I am not. Oh, it is changing. All right. So you can see that blah, blah, blah. But then at some point this goes red because current frame is probably larger than the amount of lines. So let me actually, so can I update this? Yes. So you can see that right now this is working and it's going over all the frames in the simulation, but at some point it just grows too large. All right. So that is actually quite easy to fix. So for example, let's say that I'm going to create here an input that is going to be called loop, and that's going to be of the type Boolean. All right. And then what I'm going to do here is I'm going to figure out if frame value is valid. So what I'm going to do here is I'm going to say if loop equals true, or we can shorthand this, then what I'm going to do is I'm going to make sure that current frame is not larger than the amount of LEDs. And then what I can say here is if current frame, actually I'm going to do it the other way around. So I'm going to say if current frame is greater than the amount of LEDs, so I had that somewhere here, LEDs, all right? If current frame is bigger than the amount of LEDs, then I'm going to need to make decisions. And what that looks like is if loop is true, then I would probably want to reset current frame to the value of 0. All right, that's one thing. So if I reach the end, then I want current frame to start from the beginning again. Otherwise, if that's not true, then what I would like to do, if no looping is there, then what I would like to do is to make sure that I cap current frame to the last value possible. So that's going to be if current value, if loop is too big, then I want to make sure that current frame is equal to the amount of LED lights. I think that's actually not going to work because it needs to be the current frame -1. So let me set a toggle here. All right, and this is going to go red. Yes. Let's, in order to debug, let's add here rendered frame. All right, and let's create an output here, and then here rendered frame is going to be equal to the value of current frame, so that we can see, we can have a clear view of which element is being simulated at any time. So I'm going to be here. You see that I'm rendering this frame here. And because loop is false, this is probably going to stop. Yes, and it fails. So I'm going to create a Boolean toggle here that is going to be whether if looping is false or not. And let's turn this to true. And let's change something here. And then let's make this LEDs -1 because that's going to be the last one, and LEDs -1. All right. So now this is true. And then this is going to loop when it hits the end, and it's gonna up. Well, it didn't. Why did it not? So I'm probably using LEDs, the calculated amount of LEDs. Oh yeah, it's not LEDs, it's actually the amount of frames, sorry. Where am I calculating that? I am not calculating that. So calculate total amount of frames. So sorry for that. Total amount of frames should be equal to the amount of lines that are available at the CSV -1. So that's going to be int frame count total frames is going to be equal to CSV dot count -1. All right. And that is the number that I need to, so yes, so total frames -1, exactly. So that's going to be blah, 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 and I'm not sure. Okay, and that is working, very good. So yeah, so I was making, it was not the amount of LED lights, it was the amount of frames, sorry. And then if I don't loop, then you can see that this gets stuck at the very last frame. But if I turn it on again, it reinitiates. Hooray! So this looks good. Just for the sake of completeness, I am going to add here a reset option. So that if at any point halfway through the simulation, I want to reset things, and I'm actually going to use a Boolean button. So that if at some point during the simulation I want to reset things, I can press the button and start from the beginning again. All right, the way that's going to look like is that at the very beginning, do we need to reset? And then what we say here is if reset is true, then current frame should be equal to 0. All right. All right, so we are simulating, and then I press reset, and you see how this whole simulation starts. Beautiful, and we got all the numbers changing, the transparencies, the thing is working, hooray! So we were able to create a simulation that is able to take the CSV file that has the full sequence and is able to render that sequence across and is able to simulate that sequence by turning on and off these meshes that we have generated. Okay. Beautiful. You want to see a couple examples of other simulations that I have? So let me load them to show you real quick. Okay, give me a second. Okay, so I brought in a few other files of tinkering that I did last night with the tree, whatever. So I'm going to show you, for example, this one is a sequence that I generated that takes into consideration the actual X, Y, Z coordinates and creates this virtual plane that moves up and down the tree. Okay, but we don't actually need to generate sequences that are aware of the tree or the locations of the LED lights. So for example, I have this one that basically just pulses the whole tree on and off very slowly with a sine wave. So it goes from nothing, from very dark and sort of off to like slowly increasing to full white to then full black. And then it does this in a sequence, in a loop. All right. So we can basically turn all the lights on and off at the same time. We can choose to have each one of the LEDs start at a random place so that not all of them so that each one of them is at a different cycle. So that is probably what it looks, what this is probably what this one looks like. But it's not working because I couldn't find the file because I probably didn't copy it to the folder. Yeah, I didn't copy it to the folder. There you go. So now you can see how this is very slow, but you can see how they're all going black. And now some of them are going to start turning on very slowly, and they're going to start pulsing and blinking at a different rate. All of these examples, I'm going to show you how to do them very soon, all right? Then a very similar one, but instead of just black and white, with green and red colors, so more like a Christmassy kind of vibe. So half of the lights are randomly chosen to be green and the other half are randomly chosen to be red, and then they pulse over time in this very smooth, soothing way. And because they're LEDs and you can control the full RGB spectrum, then we also have this option, which is basically oh, I don't know what it is. Something went, okay, so let me reset that. Yes, so it's basically the similar idea to the moving plane, but in this case, it's basically moving planes of RGB colors that are moving up and down through the tree. All right. Beautiful. So this was it. So this was the first part in a series where I would like to teach you how to create simulations for Christmas LED lights in a very specific way. All right. But this was a good exercise on reading CSV files, parsing information as geolocation or as color, and then creating a simulation with that. All right. In the next video, in this mini series, now what I would like to show you is techniques and tricks to generate those sequences of illuminations, and hopefully so that you can create your own CSV files with light sequences, and perhaps we can run them on my actual Christmas tree here at my place. All right. All right, so that was all for this video. Thank you very much for being here. If you found this video useful, perhaps you want to like this video, subscribe to the channel, say hi on the chat, join Discord, whatever that looks like for you. All right, and hopefully see you on the next video where I'm going to teach you how to create these illumination sequences, and I'm going to show you some examples actually running on the real Christmas tree. Okay, thank you very much, and hopefully see you on the next video.